Hello guys. Okay, so you're welcome. Today too, we are going to look at tutorial 2, problem sets. So let me share it first. Let me share it first before we look at it. Okay. Okay, so first we are going to look at tutorial 2, problem set 1. And this is the question. I hope you can all see it. So you've been given 3 stocks, that is stock A, B, and C, and you're investing 120,000 in stock A, 300,000 in stock B, and A has a beta of 1.2 and a beta of 0.98, 2.3 for stock C, and that of 1. Now let's look at question A. To achieve the same amount of risk as the market portfolio, how much should you invest in stock C and risk-free assets if you have 1 million to invest? Okay, so let's start by solving it. Okay, so with this type of question, there are some key things that you are supposed to look at. So when you check B, A, for instance, they said to achieve the same amount of risk as the market portfolio, right? Now, when you look at the question, the only information that you have on market portfolio is the expected return and that of the beta, which is the sensitivity. So that means that if we want to have the same amount of risk as the market portfolio, then we expect that the beta of that portfolio should be the same as that of what? The market portfolio. So what we can say is that now we already know that the share of A plus the share of B plus plus the share of C plus XF should always be equals to 1. It's okay. But in this case, we expect to have a beta of what? 1. So we can say that then summation of xi multiplied by the beta of I, where I is equals to A up to F, should be equals to 1. And this one here represents the market beta. So I'm just finding the weighted beta for the 3 stocks. Sorry, the 4 stocks, including the risk-free assets, is okay. Then I can say that WA. So I'm going to call each of the beta. I will say beta A multiplied by SA plus beta B multiplied by XB plus beta C multiplied by XC plus beta of the risk-free asset multiplied by weight of the asset. That asset should be equals to the beta of the market portfolio, which is 1. But this beta is equals to 0. It's okay. It is equal to 0 because this is a risk-free asset. Now, once we know that this is equal to 0, so it means this one will be vanished. Now, we know that beta of stock A is equal to what? 1.20 multiplied by the weight, which in this case is 120,000 all over the 1 million plus the beta of B, which is 0.98 multiplied by 300,000 all over 1 million all over 1 million plus the beta of C, which is 2.3, multiplied by, we don't know the share of C, so I'm going to call that one X of C. And it should be equals to the market beta, which is equals to 1. In that case, I can say 1.2. So first of all, let us divide the 120 by 1 million. So 120 divided by the 1 million, which is going to give you 0.12. So you count, this one is 0.12. So 0.12 times 120, 1.20. And that gives you 0.144. So 0.144 plus the next one becomes 300 divided by 1 million, which is 0.3 times 0.98. And that also gives you 0.294 plus 2.3 XC equals to 1. That means I can say 0.144 becomes 0.144 plus 0.294, which is 0.438. It means when I sum up these two, it gives me 0.438. But when it crosses the equal sign, it becomes negative. So I'm going to have 2.3 XC is equals to 1 minus 0.438. And that gives me 0.562 equals to 2.3 XC. Sorry. So divide by 2.3. 2.3. So you know XC is equals to this divided by 2.3. And that gives you 0.244. Now we know this, so we can now calculate for XF, because we know already that the sum of the weights should be equal to 1. That means the weight of stock A, which is 0.1, let me check, cross check, is 0.12? Yeah, 0.12. So which is 0.12, that is the weight of A, 0.12 plus the weight of B, which is 0.3 plus the weight of C. Now we know at 0.2, so 0.24 plus X of F should be equals to 1. So then I can say my XF is equals to 1 minus 0.24 minus 0.3 minus 0.12. That means my X of F equals to 0.34. Now the second question was, which stocks are undervalued or overvalued according to CAPM? So the same thing that we did. So according to CAPM, then the CAPM formula is R of I is equals to R of F plus beta into brackets RM minus RF. So RA, in the case of A, is equals to, what was our RF? The RF is what, 5%. Expected rate of return for risk-free asset is 5%. So we have here as 5%. And what is the beta of A, which is 1.20 multiplied by RM. The market rate is 15% minus 5. And this gives you 5 plus 1.2 into bracket 15 minus 5. and that gives you 17%. So 17%. That means CAPM overvalued because we were given 10.5 and CAPM is getting us 17%, so it has been overvalued. So in the case of A, we can say for A, CAPM overvalued. Now let's go to B. Now for B, R of B is also equals to RF, which is 5%, plus beta, which is 0.98, into brackets, RM, which is 15, minus 5 again. And this also gives you 5 plus 0.98 into brackets, 15.5, which is 14.8%. That means CAPM also, that means it exactly estimated it because we also had a 14.8 again, so it was exact. CAPM exactly estimated it. Now I hope you can do for the C part. So the C part I'm going to leave it to the same as, it's just that it's the same as 5% plus 2.3 into brackets 15 minus 5. So when you compute the answer, then you write it here. So that is for the B part. Now let's move on to the next question. So the next question is, so this is the next question. Suppose the stock returns. So that is problem set 2. Suppose the stock return can be explained by a 2-factor model. The firm-specific risks of all stocks are independent. The following table shows the information. That is all the information we've been given. So stock A has a beta 1 of 0.81 for factor 1 and beta for factor 2 at 1.15, and expected return rate is 16%. If the risk-free rate is 4%, what are the risk premiums for each of the factors in the model? Great. So first of all, let's write the formula. So I can say that for portfolio A, R of A is equals to R of F plus beta 1 times factor 1 plus beta 2 and that of factor 2. Now we know R of A equals to what? 16% is equals to RF, which is 4%, plus our beta 1, which is 0.85, multiplied by the factor 1, plus beta 2, which is 1.15, multiplied by the factor 2. Then we can see 0.85 factor 1 plus 1.15 factor 2 is equals to 16 minus 4, which is 12. So I call this one equation 1. Now let's go to the return on B. Return on B is also equals to 1.5. So we have return on B, which is equals to, so the return on B, let me write it. So return on B, which is also 12, is equals to RF, which is 4, plus beta 1, which is 1.45 multiplied by a factor 1 minus 0.25 multiplied by a factor 2. So then I have 1.451 factor 1 minus 0.2 minus 0.25 factor 2 equals to 12 minus 4 is 8, equals to 8. This also becomes equation 2. So you solve equation 1 and equation 2 simultaneously. I'm going to use my calculator to solve it. So I have first is 0.85, 1.15, and this one is 12. This one is 12. Then I have 1.45 minus 0.25 and 8. So you know that factor 1, when you solve it simultaneously, factor 1, which is the same as the risk premium for factor 1, is the same as, is equals to 6.49. And the risk premium for factor 2 is the same as, is equals to, 5.664 to 2 decimal places. So this is the risk premium for factor 2, this is the risk premium for factor 3, and that is all. So let's look at the third question for today. Let's look at the third question for today. This question is quite long. So you own a stock. So this is the first question. You own a stock in Lewis Company. Suppose you had the expected, you had expected the following events to occur last month. So we have the events here. First, we expected the GNP to be equal to 1.2%, inflation 3.7%, and up to the EPA. So let's look at the follow-up question. Let's look at the follow-up question. Let's look at the follow-up question. And suppose the following events actually occurred. So we had our expectations, and these were the things that happened. So the question is, discuss how each of the actual occurrences affect the return on your Lewis stock. Okay, so let's go back to the first one. Let's start. So let's start and get our model for it. Okay, so I'm starting. So first thing that I will write is, so you own a stock. So I'm looking at, suppose you had expected the following things to occur. So that means I'm going to call this one GNP that we were expecting is equals to GNP that we were expecting was equals to 1.2%. And the beta, because they said the returns of Lewis are positively related to rate GNP. That means beta of GNP is equals to, is positive. It has a positive correlation. Great. Now the next one is the government announced inflation over the inflation. So expected inflation is equals to 3.7. And the return of Lewis are negatively related to inflation. So beta of inflation is negatively related. Now the next one is C, the interest rate expected. So interest rate expected is also equals to 2.5, right? The returns are negatively related. So beta of interest rate is also equals to negative. Great. Now the D part is saying that the president of the firm would announce his retirement. The retirement will be effective from 6 months. In general, he is considered an asset to the firm. He's considered an asset to the firm. Great. So let's say I'm going to call manager president expected to retire in 6 months now. It's expected to retire in 6 months. It's expected to retire in 6 months. And the president is seen as an asset. Once it's an asset, then the beta of the president should be positive. It's okay. And then we have the E. The research data would conclusively prove the efficacy of an experiment. So if it's going to prove it, so let's say I'm saying that efficacy expected, it is going to be proved. So let's say we are going to have positive. It's going to be positive. It's a positive value. It's going to be positive. And once it's going to be proved, then the beta of it should also be positive, right? Great. Now let's look at A, B, C, D. So let's look at what exactly happened. Now they are saying that now suppose these things happened. Now let's say this thing happened. Now the government announced, suppose the following events actually happened. The government announced real GNP, so the government announced that real NGP grew 2.3%. So that means the GNP with this one, GNP actual, I'm calling it A, equals to what? 2.3, right? Now look at something. So if I want the difference, I'll say that the GNP actual minus GNP expected. That means actual is 2.5 minus expected, which is 1.2. So the difference is 1.3. Now look at something. Because the beta of GNP is positive, right? Because when I write the model, I'm going to have something like R is equals to RF plus beta of GNP. So let's say beta of GNP multiplied by GNP plus beta of, let's say, interest rate multiplied by the factor interest rate is okay, up to the last term, which is the efficacy, right? It's okay, great. So let me clean this part, because I want to use only this space to solve it. So this is what we are going to have. Now, because the beta of GNP is positive, and when you look at the GNP actual minus expected is also positive, then positive multiplied by positive is positive. That means the beta of the first one, once it is positive, then it means Louis' return will increase. So that means this is going to have a positive impact. The expected this real GNP is going to have a positive impact on Louis' returns. Now let's look at that of inflation. Let's look at that of inflation too. In the case of inflation, so let's say in the case of inflation, the actual inflation said the inflation over the previous quarter was 3.7. So inflation actual is equals to inflation actual equals to 3.7, right? So great. So inflation actual. So if I'm looking at the difference, then the actual is 3.7 minus what we expected, which is 3.7. That means equals to 0. Now in it, beta 0 multiplied by beta, we have the change equals to 0 multiplied by the whatever beta is equals to 0. That means inflation has no influence on the return of Lewis. It's okay. Now let's look at that of interest rate. So the interest rate expected was 2.5, and now we have the interest rate actual, which is equals to 2.1. So inflation actual, which is 2.1, minus the expected, which is 2.5, you have what? Negative 0.4. You have negative 0.4. Now negative 0.4, and we also said what the coefficient of interest rate was what? Negative, because they had a negative relationship. So negative 0.4 times a negative coefficient will give what? A positive. That means at the end of the day, interest rate will have a positive impact on what? And the return of Lewis. It will have a positive impact on return on Lewis because it's negative 0.4 multiplied by the negative beta, which gives you positive. So once it's positive, it means it's going to increase the return on Lewis. It's okay. So it is in the same way that you're going to use to analyze the other ones, but I'm just going to explain it. So let's look at the next one. The president of the firm died suddenly of a heart attack. So the manager is seen as an asset, and we were expecting the manager to die in 6 months, to leave office in 6 months' time. And here the case, the manager dies suddenly. That means it's going to be negative because we were expecting the man to be there for 6 months, but the man leaves all of a sudden because he's dead. And that means the impact is going to be negative. Let's say once the man is died, once the man is dead is 0. So it's going to be the actual 0 minus the expected. It was 6 months. We have negative 6. That means the impact is going to be negative. Now, when we say the research results in the material testing were not as strong as expected, we were expecting a conclusive or a result, and here's the case that we didn't get what we expected. It was below 8. That means the difference is going to be negative. The actual minus expected, we have negative, and because we had beta for that one to be positive, we are going to have a negative impact. And in the case of lab research, so results. The lab researchers had a breakthrough with another material, and that is going to be a positive impact. Exactly. Now, the competitor announced that it will begin distribution and sale of jeans that will compete directly with one of the competitor announced that it will begin distribution and sale of jeans that will compete directly with one of Lewis' top-selling products. And this is once you have a competitor, it's going to be negative. And don't forget that in the first case, we were not given anything for the gene. So gene has just been introduced. And once a competitor announced, it means we are going to have a competitor, and that will affect our returns, right? So return on Lewis is going to be negative. Thank you. Sorry, today I used 30.32 minutes. Sorry, I'll have to end it here. Thank you.